So next, next from VeloDB, Christina Xu will share about building real-time Lakehouse with Apache Flink and Paimon and Doris. Let's work hard.
Hello, everyone. I'm Christine from. I'm Christine from VeloDB. It's such a pleasure to be here, and great to meet and connect with many data professionals and my former colleagues in one place. And today I will introduce you to Apache Doris. And honestly, the timing couldn't be better. Data teams today face a consistent challenge. They need to deliver faster insight from ever-growing data volumes. And this is where Apache Doris becomes a game changer. So what exactly is Apache Doris? Simply put, it's a high-performance, real-time analytical database built on MPP architecture. And what makes Doris special is its remarkable ability to return the query result from massive data sets in sub-second time. Here, what you are seeing is Apache Doris position in a modern data architecture stack. This really matters because Doris isn't just another tool add to your tech stack. It's designed to simplify and unify your entire data architecture. Let me walk you through this architecture. At the bottom, we have a data source layer from traditional databases, streaming data, data lake, and other data. Now Doris can connect with these data sources in two powerful ways. The first approach is using the system like Spark and Flink, where data is processed and stored and loaded into Doris for storage and analysis. This is your traditional ETL path. And the second approach, and this is where things get really interesting, is through Doris' rich set of native connectors. With this capability, Doris can connect directly with these data sources and supports zero ETL and federated query, all just through SQL. At the top layer, you can see diverse use cases Doris supports, from real-time analyticals and data warehousing to Lakehouse analyticals and observability. Pretty much all the data analytics scenarios you deal with day in and day out. I know lots of you may use wire roll solutions for these different use cases, but what we are seeing from our communities of users is that Doris is becoming an all-in-one solution that makes things simple. So what makes Doris different? Why are so many organizations switching to Doris? There are three key reasons. First, Doris is built for speed. It's lightning fast. It leverages cutting-edge technologies like vectorized query engine, pipeline execution model, cost-based optimizer, and more. It's not just a marketing talk. The results speak for themselves. In real-world benchmarks like ClickBatch for white table, TPC-Edge, TPC-DS for complex queries, Doris consistently outperformed the competition. The second, it's easy to use. For administrators, it's super easy to deploy. Whether you are running on bare metal, cloud VM, and Kubernetes, it also handles things like replica balancing and self-healing out of box. For analysis and engineers, Doris speaks MySQL protocol and standard SQL. If you know SQL, you already know how to use Doris, which means less wrap-up time and lower integration costs. Third, Doris supports multiple data analytics scenarios, from BI report and dashboard to ad hoc queries, machine learning, and production analytics products, all in one engine. So you don't have to maintain multiple systems anymore. So Doris supports many data analytics scenarios, but today we will focus on how Doris address the challenge of Lakehouse analyticals. But before we dive into our solution, I want to take a step back and walk you through two key background topics that shape how we think about the Lakehouse architecture. The first topic is the difference between data warehouses and data lakes. The traditional data warehouses have several defining characteristics. They only support structured data and use proprietary storage system and require predefined schema before data ingestion and provide a standard SQL query interface. So they are excel at reporting and analytic scenarios. The advantage of data warehouses are clear: high performance, a robust data management capability, and high data quality. But they come with some significant downsides: high storage cost, limited flexibility, and vendor lock-in. I'm sure many of you have direct experience this pain point. Now let's move to data lakes. Data lakes support both structured data and unstructured data, use open file format, and works with shared storage like HDFS and object storage. The data lake are perfect as your company's unified data storage solution. They store all your raw data as is and making them ideal for your data analysis, data mining, and machine. The big advantage of data lakes is its open ecosystem, which provide flexibility and much lower storage cost. But they usually have poor performance and require more effort to manage properly. Let's shift gears and take a look at the second topic, the evolution of big data processing frameworks. As part of the evolution, you may have heard of Lambda and the Kappa architecture. Each architecture has three main layers: the data source layer, and the middle data processing layer, and the service layer. The key difference between these two architectures is in middle data processing layer. Let's start with Lambda. Lambda split data processing layer into two parts: the batch processing and the stream processing. And this design works well for a business need both real-time insight and accurate historical data for analysis or correction. But it comes with some downsides. You have to maintain two code bases and ensure data consistency between two data pipelines. And as your business grows, it also leads to more and more duplicated computation and wasted resource. And so to simplify things, Kappa was introduced. It removed batch processing, leaving only stream processing. And Kappa works well for applications that need high real-time performance, where historical analysis can be handled by stream replay. But what makes Kappa attractive is that it's simple and avoid data consistency issue in Lambda. But in doing so, it gives up some flexibility in accessing historical data. And to be honest, real-time stream troubleshooting was a nightmare at that time. And you need to put more effort to manage this real-time stream, and also with risk like data loss or out-of-data issue. So because of this stability issue, Kappa only works well for in specific scenarios, not as an all-purpose solution for most data teams. So with all of that in mind, we can clearly see three key challenges in building an effective Lakehouse architecture. The first, Lakehouse integration challenge. How do we combine high warehouse performance with lake flexibility and lower storage costs? Third, unifying stream and batch layers. Can we use one single engine and the storage system to handling both real-time and historical data analysis. Third, handling data changes effectively, not just for historical data, but also for real-time data as your business requirement involved. So how do we solve all of this challenge? Let me introduce you our Lakehouse solution based on Apache Flink, Paimon, and Doris. Yes, and the main change is happen in processing and the service layer. In processing layer, Flink and Paimon unifying batch and streaming layers. Flink achieve batch stream fusion and at a computation level, efficiently handling both stream and batch data. Think of Paimon as an enhanced version of Iceberg. It provides similar table format, but with significant improvement of real-time data update, effectively handling both real-time and historical data in one system. At the service layer, Doris handles everything. We made extensive optimizations for Paimon data, enabling faster direct data analysis. Beyond I will explain more about those technical details later. Beyond the MySQL protocol, Doris also provides the ADBC protocol, which based on Aeroflight, which is better suited for large data volume transfer, particularly in AI and machine learning scenarios, which large volumes data need to be moved quickly. And the Doris also supports a rich set of unified metadata management service, such as Ali DLF and AWS Glue and more. Yeah, once connect with this unified metadata management service, both Paimon and Doris can easily maintain a consistent schema and permission management service through catalog. So now that you've seen the overall solution, let me zoom in on one key part, how Doris and Paimon accelerate the Lakehouse workloads. The Doris community began integrating with Paimon ecosystem, starting from Paimon version 0.5, and continue to keep pace with Paimon's latest feature. Doris has implemented the native reader for Paimon data, allowing it to directly read packet or ORC file from Paimon tables. Doris also natively supports deletion vector feature, which significantly improves the query performance. When it comes to performance optimization, Doris has implemented extensive improvement for Paimon in several critical areas. The first, I/O optimization. Targeting the specific characteristics of HDFS and OSS, Doris has made numerous optimization, including small I/O merging, I/O perfection, and the delayed materialization. This ensures that user can experience good throughput or low latency, even when reading remote data that hasn't been cached. Second, data caching. Doris includes a lightweight local data caching capability that can cache the hot data blocks from remote storage to local high-speed disks. So if your query hit the caches for hot data, performance is comparable to Doris' internal table format, which is blazing fast. Third, metadata caching. Since the stability of remote metadata service can be unpredictable, we made metadata caching within Doris. This caches partition and the file list information, so it doesn't have to get them from remote storage often. As a result, even with a large table, the query plan and the required file list can be returned in millisecond time. Finally, materialized views. Doris support build asynchronous materialized views based on Paimon table. And it also supports building incrementally by partition. These materialized views are stored in Doris internal storage, allowing user to direct query them with, for great performance. And alternatively, through Doris transparent rewriting capability, the Doris query optimizer can automatically transfer your query to the most suitable materialized views without changing your original query statement, enabling transparent query acceleration. So that's how we make Lakehouse queries fast. Beyond the performance in the modern Lakehouse environment, flexibility and scalability are just as important, especially when your workload are unpredictable or your business team want to work independently. That's where Doris decoupled storage and the compute architecture comes in. In this setup, Doris uses OSS for data, and the metadata is handled by a separate service. That means BE nodes no need to keep any state. You can easily turn your computer cluster on or off, depending on your workloads. So with Paimon serving as a unified storage service, you can run multiple Doris compute cluster for multiple use cases on same data. No more data silos, no more data duplication, just one consistent view for all your workloads. It also provides resource isolation and prevent performance contention between workloads. So we've just seen how Doris accelerates query performance with Paimon, and how its decoupled architecture gives you flexibility and scalability. But in cases where you need faster ingestion or more stable query performance, we also support writing data directly into Doris with Flink CDC. The Doris community offers Flink Doris connector that comes with Flink CDC capability, providing a robust data sync solution from your transactional database, processing databases to analytical processing databases. So what makes this integration stand out? First, automatic DDL synchronization. When you create a table in your TP databases, the connector can automatically sync this DDL to the Doris and create a corresponding table using predefined rules and mappings. And through no manual intervention required. And through Doris light schema change feature, we can handle frequent table schema changes in milliseconds, keeping your analytical environment seamlessly in sync with your TP databases. Second, exactly once data sync semantics. Doris primary key models provide excellent support for data updates. And through the two-phase commit mechanism, we can ensure the data from multiple subtasks takes effect automatically with idempotent imports. Third, multi-string joins. Doris partial update feature can automatically build a wide table from multiple data streams. This not just saves the computation resource on Flink side, but also significantly improves the overall write performance of the system. So how does how well does all of this actually perform? Let's check out some actual performance results. Here we are comparing Doris and the Trino running TPC DS1 TP query based on Paimon table. The data are stored in Ali Cloud OSS, and metadata, we use DLF as our metadata service. As you can see, Doris is 3 to 5 times faster than Trino at most, across most queries. These impressive results show that our optimization provides warehouse-level performance on data lakes, while still keep it flexible and open. Benchmarks are great. Let's see what this looks like in action with a real customer case from Xiaomi. Before use our Lakehouse solution, Xiaomi data platform team need to store a similar data set in multiple systems for different use cases. Presto plus Trino plus Iceberg for their daily diagnosis analysis. Doris for their hourly level ad hoc query, and Druid for minutes level dashboard. This created a high data redundancy and a lot of maintenance overhead. After transformation, they moved to a unified Lakehouse architecture. With Doris as a unified query engine, and Paimon as a shared data layer. They also create a materialized view in Doris to speed up common queries. As a result, their average query latency dropped from 16 seconds to just 11 seconds, and their data freshness improved from 16 minutes to just 1 minute. Awesome, right? And just as importantly, maintenance got easier, because now same data set serve multiple use cases in one system. Before I close, I'd love to share a few words about the community behind all of this. Doris became open source in 2018. Since then, about 600 people have contributed to the project, and about around 100 people are actively contributing every month. Today, Doris is widely used in many companies. Looking ahead, we will keep working closely with Paimon and Flink to build an even more comprehensive data lakehouse solution. We'd love to have you in our community as we build the next generation analytical database together. Okay, I've come to the end of my presentation. Thank you so much for being here. And I hope you can see how Doris can truly transform your entire data architecture, unifying all your analytics workload, but while still keep it faster, simple, and powerful. I'd love to see you try it out. Thank you. Thank you so much.
Thank you. Thank you, Christine, for such an impactful presentation.